Hi, this is Jason Baker, and welcome to our Week 11 lecture on deployment pipelines. Now, we've worked with pipelines a little bit in this class so far, mainly in some of our classroom projects. And in this lecture, I want to formally introduce you to pipelines and to the Jenkins CI/CD server. The agenda for this lecture, we're going to cover deployment pipelines. I want you to understand from a general standpoint why we use deployment pipelines and what are some of the different components of a pipeline. And then most of the lecture is going to be focused on working with Jenkins. And this lecture is going to be a little bit different than many of the previous lectures because much of the lecture is going to be done hands-on. I'll be demonstrating the use of Jenkins and how you set up pipelines and how you manage some of the configuration. It's much easier for me to just show and tell versus trying to describe in an abstract way some of these configuration and some of these design elements. And then we'll wrap up the lecture by looking at pipeline as code. So just like everything else, just like infrastructure and configuration, all that stuff is managed by code. We can also manage our pipelines using code as well. I mentioned that this lecture is going to be very hands-on. And so, what I encourage you to do is to follow along with me as I walk through the different steps in the lecture. And you'll have the benefit of being able to pause the lecture, and if you kind of get behind, and you can and replay different parts if you're confused as to what I'm doing. So in order to follow along with me, you need to launch a CloudFormation stack, and it's the Jenkins stack, which you've already used in this course. Launch that stack, provide a username and password for Jenkins, provide your current IP address in Cedar notation, and also specify your server key. The stack takes about 10 minutes or so to launch, so you can, I won't use it in the first section of this lecture, but if you start launching it now, then by the time you're done watching this and you start watching the other sections, that the stack will be up and ready for you to use. When you need to log into the Jenkins server to look at the outputs from the CloudFormation stack to determine the current IP address of the Jenkins server. And the way you log into Jenkins, of course, is by going to port 8080 at the Jenkins server IP address, and you'll see the Jenkins login page. Okay, so the first part of this lecture is a discussion of deployment pipelines. So what is a deployment pipeline? Well, a deployment pipeline is something that we use to manage the deployment and testing of software code. And a deployment pipeline consists of multiple validation stages. Every time we make a code change, we trigger our deployment pipeline. And our code basically has to progress through each of the stages. You can imagine your code change is sort of like running the gauntlet of different validation stages within your pipeline. The deployment pipeline has a number of benefits. Every single time we make a code change, our software is going to be automatically built and tested. That means that we know if our software is ready to deploy into a production environment. And every single change we make is tested over and over and over again. So we have great assurance that our software is production ready. The pipeline also makes changes to software much easier because every single time we make a change, our deployment pipeline is triggered and our software is tested the same way. So it's much easier to sort of automate this process versus having to manually test our software changes. And back in the old days, every single time we made a change, well, usually we batch together changes, and then periodically, maybe a couple times a week, there would be a group of people that would manually test our software to see if it was still working properly. And sometimes as a developer, you would commit your code and you wouldn't get feedback until several days later. It might be a week later before you get feedback as to whether or not your code change is actually working properly or not, and if it's actually going to be merged into sort of like the production branch or mainline branch of the repository. And because we can test our software via a deployment pipeline so quickly, it reinforces this practice of making small changes to our software. So we want to be able to make small changes to our software. Remember, small batch sizes, and then be able to frequently deploy those changes into a production environment. The only way to do that is by using some sort of automated deployment pipeline. And then finally, if you're an organization that needs to comply with different regulations and different sorts of compliance requirements, then the pipeline gives you a great amount of traceability. Every single change that you make to your code is going to be tested in your pipeline, and you can store the results of those tests, and that provides you with traceability later on, if you need to, for governance reasons or for compliance reasons, if you need to go back and validate that a software change was tested when it was committed into the code base. Now, when we're developing pipelines in the real world, what you'll find oftentimes is that companies today are hiring people to focus exclusively on the development work, developing pipeline code and working with systems like Jenkins or other CI/CD systems. And sometimes companies call these CI/CD engineers or software delivery engineers. I've heard terms like release engineer or build engineer, maybe even DevOps engineer. It, uh, it- Companies are hiring dedicated engineers to work on these pipelines. But what I'm also seeing increasingly is that software engineers also need to understand how to build pipelines and have to understand how to troubleshoot them and understand how they work. So in my organization, every software developer is expected to be responsible for some pipeline development work. So every single software developer it knows how to use Jenkins and knows how to make changes and updates to pipelines. So it's not the responsibility of just one team or one specialized group of engineers. Everybody is responsible. Now, as somebody who works in an operations team in a DevOps culture, I find that I probably spend most weeks at least 25 to 30% of my time working inside a CI/CD system, working on pipelines. There are some weeks where I might spend 50 to 75% of my time working on pipelines. So software deployment pipelines are just a really critical part of the software development and software delivery lifecycle today. You really can't build a modern application anymore without having some sort of automated pipeline in place. Well, so how do you go about building a pipeline? A pipeline consists of multiple stages, and I'll walk you through kind of like a very basic pipeline and some of the common stages that you would encounter when building out a software deployment pipeline. The first stage is the local development stage. And this stage isn't running on the CI/CD system, right, on the Jenkins system. This stage is typically happening on the developer's workstation. So, in the local development stage, developers are running and they're testing their software on their local workstation typically. Sometimes they'll be testing software inside of a virtual machine, like a Vagrant environment, or on a container. Maybe they'll be using a virtual machine that the company is providing to them. But this is sort of a local development environment, a local sandbox that the developer is working in. Inside that local development environment, the developer is writing code, and they might be running and testing code locally. Oftentimes they're using some sort of code linting process. Linting is basically a static code analysis process which developers will use to identify common syntax and style defects within their code application. And I use code linting all the time, and it's a good process to enforce across a development team because you can ensure then that all of the code that is being produced by team members is all stylistically consistent. And linting also helps you identify any like syntax issues in the code. So before you actually commit that code or actually try to run it, you can identify syntax issues and defects that you can fix. So and also developers when they're working locally are oftentimes building and running unit tests. Unit tests are these very small functional tests that will test the individual functions within an application. Unit tests, remember, are designed to run really fast. You can run potentially hundreds of unit tests per second. Now, once the developer has coded the application or coded the change that they're making, they will then check their code into a version control system. So they'll commit their code to, like a branch within a Git repository. And that will oftentimes then automatically trigger a build stage in a code deployment pipeline. So this is where a CI/CD system and like a Jenkins system comes into play. That code commit to the Git repository is automatically triggering the build stage in a pipeline. And that build stage is going to do a number of different things. Oftentimes it will lint the code again. So we lint at the build stage because maybe the developer forgot to do it locally. And we want to ensure that any code that is being committed to the repository has been properly linted. So we lint the code. We might compile the code and produce some sort of binary artifact. We'll typically run unit tests again. So just like linting, we want to make sure that all of the code that's being committed has been properly unit tested and that the code is also passing all of the unit tests 100%. We might do some, sort of small, quick execution tests. These might be sort of integration level tests at this point. And then finally, whatever code or whatever artifact was generated from this build stage, that artifact is oftentimes then going to be stored in some sort of artifact repository. We're not going to store stuff on the Jenkins server or inside of what we call the workspace within the Jenkins server because everything that lives on the Jenkins server, all of our jobs and the artifacts that are created by our jobs, those things are designed to be temporary. They're not supposed to live long on the Jenkins server. So if we have some sort of build artifact that we want to store permanently, then we would we would store that in, in an artifact repository of some sort. This could be something as simple as an S3 bucket. It could be an actual artifact repository platform like Artifactory or Nexus. Those are two common artifact repositories you'll find in the marketplace. The key here is that artifact is stored in some permanent location outside of our Jenkins server. Now, after our code has passed the build stage, it's going to move on to the testing stage. And in the testing stage, our code artifact is oftentimes deployed to some sort of testing environment. And in the testing environment, we're going to run automated GUI tests. We might run automated API tests. And these are both integration and end-to-end tests. Oftentimes, we're leveraging some sort of testing framework. Maybe we're using a grid-based testing solution like Selenium to do, like UI sort of testing. We also might begin to do non-functional testing. So we might test for service resiliency. Maybe we'll do some performance testing. Maybe performance testing will actually be another stage, like beyond our initial testing stage where we do, say, UI and integration tests. Maybe we'd have a separate performance testing stage. And then sometimes what we'll do is if our code passes the testing stage, we'll have sort of like a manual halt point in our pipeline. It will halt the pipeline to allow manual testing to take place. So we'll have then human beings that are doing some manual exploratory testing to validate that our software platform is working properly. And once they manually validate that it's working properly, then they can resume the pipeline. The next stage after testing is to deploy or release our software. And in this case, our code artifact is being deployed potentially to a production environment. Maybe instead of deploying our code directly to a production environment, we'll actually first deploy it to a staging environment. And then in the staging environment, we'll run a series of automated smoke tests. Smoke tests are sort of very lightweight tests that are going to validate some basic end-to-end functionality of our platform. And they serve as a signal that our application is working properly and is ready to be deployed to a production environment. So those are the basic stages that you'll find in a pipeline. The reality is that in the real world, when you look at a pipeline, it could include many other additional stages, but they generally sort of fall in one of those different categories where we're building our software or we're testing our software or we are deploying our software code. Some other stages you might find some security testing stages. Maybe we're doing some static code analysis and we're scanning our code looking for things like SQL injection vulnerabilities. It's very popular today to scan software libraries to ensure that our software libraries don't contain some known vulnerabilities. So we'll compare those against some of the common vulnerabilities that have been reported in the marketplace. So there's all kinds of other stages that you could include in a pipeline, and it's not uncommon to find a pipeline that might have 7 or 8 stages within the pipeline. Now, when we trigger a pipeline, we trigger it when code is checked into the version control system. So code is checked into something like our GitHub repository, and that automatically then triggers a pipeline to begin running on a system like Jenkins. How does GitHub trigger Jenkins? Well, GitHub can generate what is called a webhook. So when you commit code to a repository, GitHub will see that code has changed in your repository, and it can automatically then trigger a web request, what we call a webhook, to a Jenkins server. The Jenkins server, when it receives that trigger from GitHub, then it knows that a change was made to a GitHub repository, and it can automatically trigger a related pipeline. And that pipeline then can go and clone a copy of that repository and initiate a build and the testing and the deployment and so on. So in this example chart, you see that a, a, a code commit was made and it triggered the building of a pipeline. In this case, the build failed. So the developer wrote some code and it was committed in the pipeline, and that there was some sort of problem with the code. Well, the good news is that the developer is going to get feedback right away. So when as a software developer, as you're writing code and you're triggering these pipelines, you're watching the pipeline execute. 'Cause as a developer, you want your code to get merged into the mainline branch, and oftentimes it won't get merged into the mainline branch until it passes through all the different stages in the pipeline. And so your goal is to get your code committed, and you're very aware of the state of the pipeline and whether or not your build is progressing through it. So if there's some problem with your code, you want to get feedback as quickly as possible so that you can make the necessary changes to your code and then push up another change. So this developer got feedback, they pushed in another change, and in this case, it did pass the build and unit testing stage, and it moved on to the automated acceptance tests, and it failed there. So then the developer once again made changes. They checked in their code, and it triggered the build stage. It passed, triggered acceptance tests, triggered a user acceptance test stage, and then finally was released. The one thing I want you to take away from this diagram is to note that every single time the pipeline is triggered, the pipeline begins at the very first stage all over again. So even though this developer's code progressed all the way to the automated acceptance test phase, and they made changes to their code and pushed it back in, this pipeline didn't resume. It did not resume at the automated testing stage. The pipeline effectively started all over again. So each one of these commits and each one of the triggering of the pipeline represents a brand new build. And this is an important thing to keep in mind, is that you always want the pipeline to start from the very beginning on every single code commit. You don't want the pipeline to ever resume. You need your code to begin kind of going through the pipeline at the very beginning on every new code change. Okay, um, so some of the common practices around our pipeline deployments, uh, well, we want to be able to basically, we're using our pipeline to prove that our code is production worthy. So that's the purpose of the pipeline. When you first build the pipeline, oftentimes it's sort of basic, and it's very likely that some defects will make their way through the pipeline. In other words, you won't have robust testing in place yet, at either the build or at the automated testing stages. But over time, what you'll be doing is you'll be improving your pipeline. You'll be making it more and more resilient. You'll be adding more and more tests. And your pipeline will become more and more robust and trustworthy, so that if your code is able to make its way through the pipeline successfully, then you'll have a very high level of assurance that your code is potentially releasable. When your when your code triggers the pipeline, oftentimes you'll trigger a build stage initially, and that might actually compile or create some sort of build artifact. Now, you might need to use that build artifact later on in your pipeline. What you don't want to be doing is you don't want to be compiling your software multiple times in your pipeline. That's a real anti-pattern. You want to only compile or build your software once, and then anytime you need to use that software build, you actually will then use the build artifact. You'll never ever want to rebuild your software again within the pipeline. And that's actually a common mistake that many organizations make. The when you're creating the deployment process, you want to build a deployment process that works the same way in every single environment. So you want to have a deployment process that deploys your software into a test environment, into a staging environment, and into a production environment. You want that deployment process to work exactly the same way in each one of those environments, because you're not just testing your code, you're actually using a deployment pipeline, you're actually testing your deployment process as well. So you not only have assurance that your code is production worthy, you have great assurance that your deployment process will work when you need it to. And then the last thing is just a reminder that you always want your code to begin at the very start of the pipeline and progress through all of the stages of the pipeline. If any part of your pipeline fails, then you need to stop the pipeline, fix your code, and start the pipeline all over again from the very beginning. You would never ever resume the pipeline, or try to push your code into the middle of the pipeline and resume it from that point. Your code always needs to begin and be injected into the very first stage of the pipeline and progress through all of the stages. One other thing that I'll mention about pipelines is that sometimes you're working on projects and on platforms that are fairly complicated. So there might be cases where you're not just triggering one pipeline, you might actually be triggering multiple pipelines, and these pipelines could be running in parallel. Each pipeline may be building a different component within your platform. And then once all of these different individual pipelines run, they we have they sort of trigger an assembly pipeline which assembles all the different components together and deploys those into some sort of test or staging environment. And this is a sort of a fan-in pipeline pattern, which is pretty common in industry.